In this lesson, we're going to look at writing equations of ellipses. We're going to look at a few where it's just given us information about the graph, and then a few later where it's giving us problems in a real life scenario. So we'll have things like units, and we don't necessarily know where the center is, but we'll look at that later. So let's start with number 1. So on number 1, it tells me the endpoints of the major axis are here and here. So we have to notice this y value is not changing. That means my major axis is moving along the x values, so it's moving horizontally. So this is going to be a horizontal ellipse. Because the y values aren't changing, I'm not going to look at the y values because I know they're all 2. So I'm going to go from -8 to 10 for my major axis. Well, I know that -8 to 10 is a length of 18. So that tells me that my a value is half of 18, which is 9. Okay? Now the next piece of information it gives me are the foci. That's that c value. So it's at 6 and -4. So we'll put the -4 over here and the 6 right here. And I know the center is in the middle of that. That doesn't tell me the b value, but I can figure out c. So to figure out the center, I'm going to figure out what's the middle of the 2 foci. So I want to find the midpoint of these 2 points. Remember midpoint formula from like algebra 1, where you add the x's divided by 2, add the y's divided by 2. So 6 minus 4 is 2 divided by 2. 2 plus 2 is 4 divided by 2. So my center is at 1, 2. So we'll say the center, we'll use 1 because I know everything else is 2. So how do I get from 1 to -4 and 1 to 6? Well, that's 5 in both directions. So the c value is 5. Now the only other thing we need to actually write our equation of this ellipse is the b value. So remember the formulas, it kind of looks like Pythagorean theorem, but it's a squared minus b squared for foci. So I'm going to say c squared is a squared minus b squared. So you do have a calculator for this section, so I'm going to do 5 squared minus 9 squared to get -56. But b squared is negative, so I can ignore the negatives. And I know that b is going to be the square root of whatever 56 is. And I'm going to leave it like that for now because in my formula you'll see we'll square it. So to write the equation of this ellipse, we have x something squared plus y something squared equals 1. So this is where the center goes. So x minus 1, y minus 2. This is a horizontal ellipse, remember, because the x values were changing. So my a value, 9 squared, is going to go under x. So 9 squared is 81. And then b is going to go right here. Now I left this as a square root because to go in my equation, I have to square it. So if I square this, it's just 56. And there's the equation of our ellipse. Let's do another one. Okay, the major axis is 16 units long. That means A is 8. It's parallel to the x-axis. This tells me that it's horizontal because the x-axis is horizontal. The center is at 5, 4, we'll need her. And the minor axis is 9 units long. That tells me b, half of 9, is 4.5. Now we don't need c to write the equation, so I don't need to find her. And I'm just going to go ahead and start writing what I have. So x minus 5 over, this is horizontal, so the bigger number, 8 squared is 64, plus y minus 4 over, I don't know, 4.5 squared, 20.25 equals 1. That was an easy one. Okay. Ellipse with vertices at 5, 0 and 5, 12. So notice this time the x value is not changing. So to get from y to y is 12. The minor axis, so this must be the major axis. So A is half of 12, which is 6. The minor axis from 1 to 9 is 8. That means B is 4. The only other thing we need is the center. You can pick either one of these and do like we did up here where you find the midpoint because the center is in the middle. I'm gonna do this first one. So to find the center, 5 plus 5 is 10 divided by 2. 0 plus 12 is 12 divided by 2. So my center is at 5, 6. Now we just gotta plug in all the information into our equation. So we have x minus 5 squared plus y minus 6 squared always equals 1. Now remember, for this one, the major axis, the y value is changing. So this is a vertical ellipse. So this 6 squared, the 36, is going to go under y. And then 4 squared, 16, is going to go under x. Yay. Okay, so that's when you're just given information based on a coordinate graph. But now let's look at some real life scenarios. The statutory hall in the United States Capitol is elliptical. It measures 46 feet wide and 96 feet long. Okay, I'm gonna draw that. It doesn't matter how you draw it, our answers will be the same. So I'm gonna say this is 96. Is that what it said? Yeah. And this is 46. So what that tells me so far is that my major axis, 96, A is gonna be half of that, so 48. And then minor axis is 46, so B is 23. Okay, if a person is standing at one of the foci, so here can be a foci, and here can be a foci. Her whisper can be heard by a person standing at the other focus. How far apart are the two people? Well, we know that the distance from the center to the focus is C. Center to focus is C. So if I need to figure out how far apart these two people are, I need to figure out C, but then that's not my answer because my answer is 2 C's. So I have to find C and then multiply by 2. So good thing we have that formula. C squared is A squared minus B squared. So 48 squared minus 23 squared, we'll square root that. 42.13 we'll say. So that's C. This is not my answer. I need 2 C's to figure out how far apart they are. So 2 times that 42.13. So my calculator, I'm gonna do times 2. 84.26. And because this is a real life scenario, let's look at our units. They measured in feet. Yay. Oh, sorry, something I didn't talk about. This did not give us a center. In real life scenarios, we would always assume the center is at 0, 0. That didn't really bother us on this one because we weren't writing an equation. But anytime you have an ellipse or something like that in real life, you're not technically on the graph, so you just assume the center is 0, 0, which makes things really easy. So let's keep that in mind when we look at number 2 now. An arch in the shape of an upper half of an ellipse is used to support a bridge that's over a river. Cool. So let's draw our river. Here's my bridge. That's half of an ellipse. The river is 20 feet wide. The center of the arch is 6 meters above the river. See figure, here's my figure, good one. Write an equation for this ellipse. Okay, so half of this is gonna be 10. This is already in half, so it's 6. So my A value is 10 because half of 20 is 10. My B value is 6 because again, this ellipse is already cut in half. So the whole minor axis would have been 12. Now to write my equation, I don't need a solve for C. We don't use C in our equation. So I already have everything I need. Again, in real life, we assume the center is 0, 0. So it'll just be x squared plus y squared. And then I'm gonna assume that this is horizontal, so the 10 will go under the x. So 10 squared is 100, 6 squared is 36. Woohoo! Okay, one more. An elliptically shaped garden. So here's my garden. It's surrounded by a wood walkway. So it's got like a sidewalk around it. Okay, the garden is 12 meters long and 8 meters wide. The walkway is 3 meters. So I have 3 here, 3 here, 3 here, and 3 here. Find the equation describing the garden and the walkway. So I need the equation of this whole picture. So this is where they try to trick us. They want us just to do 8 plus 3 to get this, but 3 is on both sides. So you're really doing 8 plus 6. So we get 14. And not 12 plus 3, but 12 plus 6, because there's 2 sides. So 18. There's our A and B. Half of 18 is 9. Half of 14 is 7. We assume the center is at 0, 0. So let's write our equation. X squared over 9 squared is 81. Y squared over 7 squared is 49. And it always equals 1. And there's writing equations of ellipse. Oh my goodness. You get to try the same type of problems on page 10. Work on page 10, try them out, and don't forget to check your work with the answer key on Schoology. Bye-bye.